Hi everyone! Today we will learn how to perform a DR test in a senhasegura clustered environment. I'll be using a 2-node cluster in this example. On the right I have my secondary node and on the left the primary node. You can also use the tags at the bottom to double check. The primary node uses the tag production, whereas the secondary node uses the tag contingency. The application is disabled on the right, but it shows the button Become Master Node. In this video, we will simulate a disaster with a sudden shutdown of the primary node. If this happens, the secondary node will automatically enter into split brain mode, and as expected, the database will go into safe mode, and human intervention will be required. Before we start, it's really important that you take a snapshot of each instance because we will not shut down the primary node safely, and it is better to have a rollback plan in place in case of any unexpected consequences, okay? So, do not perform the next steps if you don't have a snapshot. Well, first let's make sure our two instances are clustered together, and we can do that by looking at the cluster size -2. And also by looking at cluster members. Next, it's really important that the secondary node is set up in a way that allows for the recovery steps that we will need to cover. Go into Orbit, Settings, Recovery. Here, we will have to add the origin IP addresses. When we enter into split brain mode, the only way to recover from this scenario is to have a button similar to the one you see at the bottom right. However, this button is not enabled by default for all users. Only the IP addresses listed here have access to this button. In other words, only the origin's IP you explicitly added to this list will be able to recover a senhasegura instance. Okay? Before I recorded this video, I went to CMD, ran the command ipconfig, and learned the IP address of this computer. And you can see it here. If you're using a VPN with dynamic IP addresses, you might want to investigate the possibility of using a bridge server. This will make this process easier for you. Another option is to use the CIDR notation. For example, you could type 192.168.10/24. This is an extremely important step, guys. A mandatory one, I would say. Senhasegura does not accept wildcards. That is, you can't type 192.168.10.*. And if your origin IP is not listed here, you won't see the Become Master button and you won't be able to recover the instance. Having said that, I'll suddenly shut down the left node to force an error. Okay, this one is down now. Nothing happens if I try to click any links here on the left node because it has been disconnected. And on the right, as expected, the secondary node has entered into split brain, and I now see the Become Master yellow button. Press this button to recover senhasegura's instance. You will be prompted with a confirmation message, and I will confirm this option. This process may take up to 5 minutes, so wait until the process is complete. Done. Now that the process is over, we were able to recover the instance. And you can see that all the links are working again, and the web interface is responding. But there is something else we should keep in mind. Although I have recovered the instance and I can fully navigate the web interface, the modules are still hidden because the application remains disabled. To fix that, go to Settings, Application, enable the application, and then hit Save. You should now log out of the application and log back in to see the changes. Type in your username and password. Great, and I'm in. Perfect. Now, if I go to the left-hand side and open the modules menu, I can access all the different senhasegura modules. With that, you can use the secondary node to start sessions, change passwords, and perform any tasks usually run in the primary node. Now, let's move on to recovering the primary node. I'll turn that computer back on and it should sync back to the cluster automatically. In other words, it will turn back on, connect to the secondary node, recognize it as the new master node, and automatically sync all the data sent from the secondary node. That means that any changes made to the database while the primary node was down will be updated there. Let's do that now. Okay, this node is back on, but it may take a few minutes to fully sync with the database. I edited the video, but my reboot took roughly 3 minutes. I'll now refresh the page. And as expected, I was redirected to the login screen. I've logged onto my account on the right. When I log back here again, and now it's responding. And now I can even see the Become Master button in the bottom right corner, because the secondary node continues to be the master node, actually the node on the right, right? I'll show you how that works in the terminal as well. It will make it clearer. Because the left used to be the primary node, whereas the right used to be the secondary node, right? But if I run the command orbit application status on both, we can now clearly see how the cluster has changed. Because before the shutdown, the left node was the main node, but it was suddenly disconnected. The split brain mode led us to click the recovery button on the secondary node, and this made the secondary node turn into the primary node, and with that, the main node. And when the node on the left was turned back on, it synced back to the cluster, identified the change in node hierarchy, and abdicated the primary status. So now, on the left, we have the secondary node, and it says here that the primary node is now ss_lab_cont. It also tells us that it is no longer the main node. Now that the problem has been solved on the left node, we can switch them back to the right places. Run the command orbit application master, and then disconnect the node on the right so it returns to the cluster in standby. That was it for today.